This is Team Mythical Techies presenting Keeping It Hygienic, predicting health violations of Boston restaurants. Implementing food safety ordinance is of utmost importance. Health department has limited time and resource to conduct inspections over a large number of restaurants. Here with the Yelp academic dataset, we would be using data mining techniques to predict inspection scores of the restaurants. We have considered two datasets, first one being the City of Boston Open Dataset. This consists of more than 38,000 historical violations for over 1,900 restaurants in Boston. Second one being the Yelp Academic Dataset. This consists of a large number of details about every restaurant in Boston. Here we have taken into account the business dataset, which consists of details about restaurants, review dataset containing the Yelp user reviews. There are a total of about 2 lakh reviews, tip dataset containing the user tips provided. A problem statement is to predict restaurants' health violations based on the historical violations data and the help dataset. This project is a motivation from the challenge on the driven data site called Keeping It Fresh. Our project architecture is as follows. We have used MongoDB to store the data sets. We've used Python scripts to pre-process the data. This took a majority of our time in our project timeline. We have then selected relevant features from the Yelp academic dataset. We have chosen a total of 323 features. We have made an attempt to use PCA for dimensionality reduction. We then applied naive-bayes, KNN, and decision tree algorithm and compared it against zero-hour algorithm. The result of this model is analyzing the classification accuracy of each of these classification algorithms on our dataset.
We have two different data sets here. One is Boston Health Violation dataset. This is one of the records from that dataset where single star represents minor, 2-star represents major, and 3-star represents severe. As you can see, the minor ranges from 0 to 15, which we have divided in 3 classes: 0 to 1 in 1, 1 to 5 in 2, and greater than 5 in 3. The second class score range is major, where it ranges from 0 to 3, which we have divided in two classes, 1 and 2. And for severe, we have 0 to 7, which we have divided in two classes, 1 and 2. Hence, we have used multi-class model for minor, whereas for severe and major, we have used binary class model. The second data file which we have is Yelp reviews data set, where it has all the attributes related to a restaurant. As you can see, there are multiple attributes which are nested. So as we have a lot of attributes, we have to use dimensionality reduction methods. One of the method is PCA, which finds all the correlated attributes and tries reducing the features by merging the correlated attributes. But as you can see, our attributes are independent, and hence the PCA didn't give us a great improvement in our accuracy. The second approach was feature selection, where we, according to our intuition, selected the attributes which are relevant for our analysis. And these are the attributes which we have selected. Out of these, multiple attributes are nested, which we processed, and we got over more than 300 attributes, and we merged all these attributes and gave the final resulting CSV file to our classification model.
So let's look at the classification algorithms. So we started experimenting with various well-known algorithms that were taught in class, and we shortlisted on 4 such classifiers. We use zero-hour classifier, which is one of the simplest classification algorithm, as our benchmark for analyzing the performance of other classifiers. We use scikit-learn to code these classifiers. From the graph here shows the results of the various classification algorithms, the accuracy for minor, major, and severe violations. So we can see that the major and severe violations have better accuracy compared to the minor. This is because data is skewed for major and severe violations, and hence minor violations give us a better picture of the classification accuracy. So one of the first classification algorithms that we chose was naive-bayes. We chose this model classifier because it's easy to construct and performs pretty fast. From the graph, we can see that it performs slightly better than zero-hour and considerably poorer than KNN and decision tree. This is because it does not perform any implicit feature selection, and it does not work quite well for large data set. So coming to the second classifier that we chose was KNN. So we wanted to build a model that classifies violations based on nearest neighbors. So the very well known problem with nearest neighbors is the curse of dimensionality. So we wanted to apply PCA as previously said, and it didn't quite work well on our classification algorithm. So we ran KNN for different values of k ranging from 1 to 20 and found out that for k equal to 9, we had an optimal performance. So the final classification algorithm is the decision tree. It performs implicit feature selection and it's very easier to construct and performs considerably fast. So this can be validated in our results and we can see that it outperforms snare-based 0R and KNN algorithms. Its accuracy is it's about 56% for minor violations. So this higher performance can be attributed to the fact that it automatically chooses the attributes that are relevant and chooses the top few nodes of the tree at, as the nodes of the tree. So these are the numerical results of the graph that shown in the previous slide. So the things that worked were the pre-processing stage, the loading data into the MongoDB and pre-processing the data into the required CSV format. These worked quite well. And along with that, the classification algorithms that we applied and analyzing its accuracy, precision, and recall worked pretty well. So the major hurdles and the things that didn't go quite well were the dimensionality reduction using PCA. As previously said, the most of the features in the dataset were uncorrelated, and applying PCA didn't quite improve the accuracy of the model. And also the dataset for major and severe violations were not spread in the large range as compared to the minor violations, and we had to model them into a binary classifier. And since the dataset was skewed in this particular case, it gave it a biased result. And finally, we'd like to conclude saying that we made an attempt to predict the health violations based on the historical violation dataset and the ELP academic dataset. We modeled this problem into a classification one. And for minor violations, we classified this prediction into 3 labels, while for major and severe, we classified into a binary classification model. And from our results and analysis, we found out that it works pretty well for minor level of violations. Thank you.